close till I get up. Time is barely on our side. I don't wanna waste what's left.
Hello and welcome to this live stream on Twitch. In this live stream we will take a look at the LDSO, which stands for Direct Sparse Odometry with Loop Closure. This is some kind of visual SLAM algorithm, visual simultaneous localization and mapping, and the goal is to take an image sequence and try to estimate how the camera was moving and trying to estimate the map as well. So recreating or reconstructing a 3D point cloud of the environment that was filmed. And the goal of this live stream is to dissect this algorithm, to understand how it is working. And I'm not an expert of the LDSO, I'm trying to learn it, so I thought, well, let's try it together. Okay, with this introduction out of the way, we can start and actually take a look at how the LDSO is working if it is programmed the way it should be. So here on GitHub you can find the source code. It is licensed under the GPL 3.0 license, and yeah, you can just download it and compile it. The introduction or the instructions are quite easy. You have to run 2 shell files and that's it. Okay, so I have downloaded the source code already and will now run it here in my terminal. I've prepared a short shell script that allows me to just run the whole command line. I will show you that. So this is the script. I'm just calling the binary file, one of the 3 binary files that is shipped with the LDSO. And I pass some arguments like a preset and the files, where are the images, where is the vignette, the calibration file, the vocabulary, and the gamma calibration. Okay, if I run it now, it will take a short while. But here the LDSO is starting, and you can see in the terminal that it is currently initializing. This is one important step. So in the beginning the LDSO is taking the first few images and trying to estimate like a starting configuration. That is, for example, a velocity, and so a linear velocity and a angular velocity. So just an initial kind of motion. And the LDSO takes about 7 to 8 frames in the beginning and will then operate as usual. So let's wait for this. And as a side note, I'm using a debug build here, so it will take a longer time to execute the LDSO. Usually it is able to operate in real time. Okay, so now we are at frame 7. It should start soon. frame 8. Let's see. Okay, so now it is running. You can see the images showing up on the left hand side here, and in this 3D view you can see how the camera motion is being estimated and the 3D point cloud is being reconstructed. You can take a look around, and the more images you have, the more detailed the point cloud will look like, and the more accurate, you could say, the result will be. There's a lot going on here, and it will be complicated to take a look into the source code. It will not be easy, and certainly a lot of stuff will probably be not easy, or at least for now it will still be not possible to explain it. But as I said, we will see how far we get, and we'll start from the basics. We'll build up a foundation and try to understand as much as possible in this implementation. Okay, so I think it is quite clear what this is about. Now let's get to work. What I have prepared here is, if you take a look here, a second folder structure which is called LDSO Twitch, and we have this original LDSO code here, and this folder is empty. And this is where we will begin to code up everything that is included in this original LDSO code, but we will build it up from scratch so we can discuss all of the details and maybe the complicated parts and the easy parts and the really confusing parts. Yeah, that's the plan. I don't know how it goes. It's a live experiment, so to say, and I hope it will be completed at some point. We'll see. Okay, so I have opened this folder in the Visual Studio Code tool, and I would say we start by creating the first file that we need, which is the make project shell script. If we look here, we will see that there's a compile script, which is the make project shell script. Okay, so let's create a new tab here. Let us continue with the LDSO running in the background. It will take some time. As I said, it's the debug build, so it will take a long time. But simultaneously, we can, of course, create our code here. Okay, so let's take a look. I want to change directory into LDSO Twitch. And then I want to touch the make project.sh file, which we then open in Visual Studio Code, and we start programming here. So we can start with some variables. We can set a build type, which is equal to release. This way the code will run faster, we will not have the debug symbols, and we can test it faster, but we will not have the ability to step through the code. I would say in the beginning it's not necessary to step through the code and debug it, because in the beginning the file will be quite simple, and that's why we can just start with the release build. Next we can define the number of processes, so numproc equals 4, to say that we want to compile the code with 4 processes. Next we define a base directory. Let's call it this way, and define it with the environment variable of the current working directory. Next we will be able to define the executables. We will have 3 of them. The first one, for example, is no, sorry, I mixed up things. Sorry. We'll have to add libraries. For example, the bag of word 3 library. And we will also add the G2O library. So the bag of word library here is useful for recognizing past places. So if we have an image sequence and we go around in a loop, we'll find loop closure candidates and can then optimize the past trajectory. So here in this case, for example, if the camera starts moving in this way here and then comes back to the initial place, the algorithm will be able to globally optimize the whole trajectory to have as few errors as possible. You will notice that if the camera is moving, errors will accumulate over time, and the trajectory will not be able to be reconstructed the way it should be. And loop closure is one way to fix this, basically. And the G2O library is useful for optimization and is actually performing this optimization, this trajectory optimization, or this loop closure, for example. Okay, and as a last step, we want to compile our project. And those are the 3 steps here. Okay, so let's start with building the bag of words library. So we change directory into our variable base dir, and in this base dir we will have a directory called third party, which is called debo3. Then we will create a new directory, make dir, which is called build, and then we change into this directory, and then we make we run the CMake command with the CMake argument, the CMake build type. And then we run the make command with j, for example, in this case 4 or 8 or 9, whatever, we just add the number of processors here. Okay, so that's it with the first library, the bag of words library. Next, we just copy the code and add it again here. And we now compile the G2O library. G2O. We create another build directory here, change into it, set the build type to release in this case, and make the project. And lastly, we compile our main project. So we just change into the base directory. We create a new build directory, we change into it, and as usual, we set the build type and make this project. Okay, so that should be it. What is missing now is, of course, the Debo3 library and the G2O library. I will just take that and copy that from the LDSO library. So here's a third party folder, and yeah, let's for now leave the other libraries here. Copy that into our directory here, make a new folder, third party, and paste that here. We can delete the build library here. Here as well. And let's hope that at least building the libraries will work. Let's try it out. So we run the make project shell script. Permission denied. Need to change permissions. I like to do this via the properties panel here. Allow executing file as a program. And now it should work. Okay, so it's not doing nothing and not doing anything. I mean, which is weird. Let's take a look why this is. I did not save the file. That's the reason. Now let's try it again. Okay, there have been some warnings, but we will see if it at least will build the library partly. Okay, so it has built the G2O library, obviously. And what about the bag of words library? Let's take a look. It's G2O. Okay, and Debo3 was also built, it seems. There's a version warning, but we should be fine here. Okay. Looks good. And now we have this warning that we have an extra path. Okay, let's take a look if the build folders have been created. Yes, this one is here, and the other ones have been created as well. Okay, good. Okay, what should be next now? Oh, we have an S here. This is not good. Okay, this should be fine. Now we need a CMake lists file, because this CMake command will take a look while being in the build folder. It will take a look into the parent folder, which is designated by this or defined by those two dots. And in this parent folder, it will look for a CMake lists file. Okay, so let's create this file. Oops, CMake lists.txt file. Okay, and here is the interesting part, because here we can define where the source files are, which should be compiled and linked into the final executable. Okay, but let's start with the basics, which is to define a CMake minimum version, CMake minimum required, and then version, which is 2.8 in the case of the LDSO. Then we define a project, which is called LDSO, but in this case, Twitch. Okay, next we need to check for the build type. And set it if necessary. So if the CMake build type is not set, and also the CMake configuration types are not set, then we want to set them. Set CMake build type, oops, to release. We can add a message for example, the CMake GUI, where we can set the build type. We want to force that. Next, we can show up a message of the status, setting the build type to CMake build type. So in this case, release, as none was specified. And we need to set the property. The build type property strings, debug, and release. And min size rel and rel with deb info. And then we can end the if statement. And next we need to To check for the C++ standard. So if this variable here, the CMake version, is version less than 320, we want to set CMake CXX flags with the standard, which should be C++ 11 in this case. Plus the remaining CMake CXX flags. Oops. Okay, else want to set CMake CXX standard to 11 because it's the C++ 11 standard, and two other things as well. The one is the standard required, which is on, and the CXX extensions should be off. And then we end this. Okay. And then there's a nice comment in the original LDSO code, which reads costume modules, which in my view should be custom modules, I think, but I'm not sure. I'm not the author of the LDSO, and this will be defined as a list. We append CMake module path with the variable project source dir and then CMake. Okay. Then we want to create two new folders for the binary and library. CMake runtime, output directory. We set this to our project source dir /bin for binary, and we also set the library output path to the project source dir /lib. Okay, next we want to find the package. So this is about the required libraries. Which is, for example, the eigen3 library, which is required. The eigen library is useful for vector, matrix, and linear algebra in general. Then we have the next package, which is OpenCV, of course, which is useful for any kind of image operation, reading image files, writing image files, and doing image processing on that. We want to find another package, which is the glog, the Google log files, the Google logging system, which is also required. And last, we want to find Pangolin, which is a library for visualization. So what you can see here, this point cloud visualization and the trajectory and the whole user interface that I can rotate the view, I can move around. I have my camera path in yellow, I have my cameras in blue, which in this case is the current sliding window, and my active camera, which is the most recent frame here. This visualization is very important for Visual Slam, because if we do not have a visualization, we will not see anything and we cannot judge or see if things are working or not. And unfortunately, this will increase the complexity of our code dramatically. Okay, so let's save this for now, the CMake lists file, and let's see if we can compile that with the make project file, and we will have an error here. With our own part. Find glog CMake. Glog. Okay. Where's the glog? Here. Find package glog. Let's take a look at the LDSO directory. If there's something like that here. So find eigen CMake. Okay. Ah yeah. I see. Here's the CMake library, the CMake folder. And in the CMake folder we have the important files. So let us just copy this folder. Into our own path, and let's see if this error will vanish. Okay, great, it works. Eigen was found, glog was found, and the others as well, it seems. Okay, nice. And there was another library, I think, here. The libzip. Okay, so this library is useful for unpacking zip archives, which will be the case if we take a look at the dataset, which is from the TUM website, the sequence 45 for example. You can see that in this file with the dataset we have the images zipped in an archive file, and this should be unzipped when the LDSO is operating, and in order to do that we need this zip library. Okay, so let's add it to our CMake lists file, which is simple as find package and then libzip white. But this is optional. And therefore we could also just unzip that folder on our own and it would still work. Okay, now we want to set some additional flags. With the set command, CMake C++ CXX, I mean, flags, like this, and we add the all argument, no deprecated, March is native, no duplicate declaration specifier, no ignored qualifiers, no reorder, and no missing braces. And if not Apple, I want to set CMake CXX flags to the CMake CXX flags, and also add pthread, parallel threading library. And of course we need to end the if statement. And that's it. Let's take a look at how this looks. Okay, so this is taking a turn here. And let's try to rebuild the project. And now we have a warning. That something was not found here. But this should be okay, I think. I do not see any problem with that at the moment. Libzip. Quiet. Should be okay, I think. Okay. Ah, I see. There's something missing here with the decision. If we have ziplib, let's call it ziplib. So if lib zip library is set, we print out a message found zip lib at the libzip version, or not at, but just print out the libzip version, compiling with zip capability. And we add the definitions. Has zip lib equals 1. And we also have the include directories for libzip. Include the zip. And libzip include the zip conf, whatever this is, to be honest. Else we print out a message which is telling us not found ziplib. With the libzip library compiling without zip capability. And we set the variable libzip library to an empty string, and we end the if. Let's see if this changes anything. Okay, found ziplib. I don't know why this warning is showing up here, if it is finding the zip library. I don't know if I need to rename this to this. We can try that. I don't know. Maybe I have changed this in my LDSO version. It definitely makes more sense to have it like this instead of this other kind of lowercase or title case. Alrighty. So this works now. And what is now left to do is to add the include directories, and then we need to yeah, that's it basically. Okay, so we now add the include directories, which are quite a few here. So first we take the path of the eigen3 include directory, and the other libraries as well, which is the OpenCV include directory and the glog and pangolin. Maybe I can comment that. So eigen3 is linear algebra library, is a linear algebra library. This is an image processing library. This is a logging library. Oops. And this is a visualization library. Okay, and next we have our own include directory, which is of course the project source directory. /include, which will be a directory we will create in a minute. Get rid of this comment here. And next we have the third party directory, which contains two important directories, which is the G2O directory and the debug of words 3 directory. And I will rearrange that because in this make project this was in a different order, so we'll also keep this ordering here. Okay, this should be fine. Let's still try to compile the project. That's okay. Let's check the visualization. Okay, it is slowly getting back to the starting point. Now we need to set the third library, the third party libraries. Third party libs. We set this this variable here to simply include the ones we just defined. So this is the OpenCV libs, which should be shipped with the OpenCV installation. And we also add the glog libs, which is called differently, glog library. And pangolin is, of course, again called differently. And we have the third-party libraries as well. And the last one is the libzip library. And we need to now complete this path. So it's third party /G2O. We need to rearrange the ordering in a minute. Lib G2O. And then we need to add the extension, which is available in the CMake variables, which is CMake shared library suffix. And for the debo, bag of words, third party debo 3 build source lib debo 3 and then the suffix. I hope this is correct. Let's switch the ordering here. And let's add the subdirectories. Add subdirectory for the source. So here will be the main source. And we also want to add a subdirectory examples. And both of them contain a separate CMake lists.txt file. And I think we start with, should we start with the examples? Probably this should work. But the source files, of course, the source folder contains all of the stuff that is being used in the examples. So we might need to find a way to get around this problem. Okay, but this should be everything for the CMake lists file in the top level. Let's take a look at the LDSO, which is running. And let's make the project. Okay, so we have errors, which is not very surprising because the source and the examples folders are not available. So let's create them now. Create a new folder, source, and another folder, examples. And then this should be fine. Although the CMake lists file is not contained there. Yes, okay. So we need a CMake lists text file. Let's copy this name. And create this file here. Oops, that's not what I wanted. CMake lists text. And here as well. Now Now let's see if this works. Okay. Cannot create directory build file exists. Ah, okay. All right. That's fine. All right. Let us now take a look into the examples folder and the CMake lists file of the examples. So here we have 3 types of example binaries. All target different types of data sets, namely mono, take this into another line, mono, iRock, and Kitty. Those are well-known data sets for visual slams and visual odometry and autonomous navigation. So this will be supported in the final example binaries. And we now need to add those binaries here. We do this by add executable, and we name that executable. For example, run DSO, should be LDSO usually. I don't know, I don't want to change this at the moment, but we will take a look later. Run DSO mono, and the corresponding implementation is run DSO mono.cc. Then we need to link the libraries for this target. Libraries for run DSO mono. We want to have the LDSO with the variable third party libs. So we just want to add the LDSO library and the third party libraries, which I now notice that it's not LDSO in our case, but the project is LDSO Twitch here in this case. So I think this should be written like that. Okay, and then here follows iRock and Kitty. We will skip that in this stream, because I do not have the datasets downloaded at the moment, and I think the mono dataset, which you can see here, is fine for the first testing. This looks pretty awesome. I have to say that I have a huge respect how just anyone can create such a nice reconstruction and such a great tool here. So props to the authors of the LDSO which is the Professor Daniel Kremers and the Jakob Engel and Vlad Koltun, I think. Let's see, let's double check that. I don't want to mix up names. Ah, okay, yeah. Koltun and Gao and Wang and Nikolaus Demmel for the LDSO. So we have the DSO, the direct sparse odometry, and the direct sparse odometry with loop closure, which is the successor for the successor of the DSO. Okay, so that's it. Let's save this and let's double check. Do we have this variable set, which is called third party libs? Let's copy that here. Third party libs should be okay. LDSO Twitch should also be okay. Just to double check. Okay. Let's recompile. And we have a problem that we do not have this file, which is okay. We'll create this in a second. And that's why the target will fail here. Alrighty. Let us create this file. So in the examples folder, we want to have a new file, which is called, not this one, come on. Let's call it run DSO tum mono.cc. Just as it is written here. And let's take a look at what we need for that. I think here we are at the main or the heart of our implementation, which is the main function. Oh, it's the wrong comment. Oh yeah, sure. 2 slashes. So we need a function. Well, do we need that? I think we need it, but let's try. I think we need it definitely. Oh. Okay, cannot find LDSO Twitch. LDSO Twitch. Okay, so this was wrong. LDSO Twitch. I was actually hoping that this should work. Let's for now delete this and try it again. Cannot find LDSO. I need to think for a second. Please bear with me. Now we can see the effects of drift here. That in this case, this part, this, I don't know, this kind of cube shape here is reconstructed twice in the trajectory, and this is not something we want, and that's why we need the loop closure, which will hopefully re-optimize the whole trajectory at some point if loop closure is activated in this case, what I'm not sure about at the moment, and then it should merge those parts of the trajectory here and also rearrange the rest of the trajectory. We'll keep that in the view at the moment while I will think about the reason why the build process is not working at the moment. Let's turn on the music.
inside my own world of make-believe. Kids screaming in their cradles, profanities. I see the world through ice covered in ink and bleach. Cross out the ones who heard my cries and watched me weep. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush.
Okay, I think I know the reason why the LDSO library was not found. Oh, let's see if the post graph will now optimize the trajectory. Something is moving slowly. Set GUI refresh. No, it did not work. Weird. Wait, loop closing to join. Find loop closing thread, need finish flag. Loop closing thread is finished. This does not look like a successful loop closing here. Okay, now to find the error here, one should be able to understand the code, and this is what we are trying to do here. So maybe we will find the reason why this is not working. There is little to no clue why this did not work, so we need to investigate that further. But let's continue from the beginning, and the beginning is to use the LDSO library for linking, and in our case this will definitely be called LDSO Twitch. So let's leave this here to be the same as this one. But now what is missing is the CMake lists file in the source directory. This is what we need, because here we will add a library which, who would have been expecting it, is called LDSO Twitch. Now here we have all of the source files, which we will add later, not now. Next we want to target link libraries. And once again we want to add LDSO Twitch here with the third-party libs. And I think this should work. Let's see. Okay, no source is given to target. That's true. Let's see what we can do here. Let's add the feature.cc file, for example. And this is in the source files, so we create a new file, which is called the feature.cc. What is a feature? Well, you can think of a feature if you have an image here. A feature is one salient point in the image. So for example, this corner here, or this drastic change from bright to dark. This could be a feature, a line feature, for example. Or this whole area could be a blob feature or a plane feature. Those are the features that are usually used from or by the Visual Slime system to reconstruct this kind of map here. All of those points here are point features which have been detected in the images before. Okay, feature CC is for now fine. Let's try to rebuild the project. Okay, now we have a different error which states that we do not have a main function. That's true as well. So let's create the main function in what file? In our run DSO to mono for this binary file here. So let's go to the CC file here, and the comment says it all, but it's still missing. So we need to add a main file, a main function I mean, which consists of argc, and argv, which is I think an int here and a char pointer. I have to look it up quickly. I know that's the HelloWorld example, but still. Okay, int argc is fine, but of course this is a double pointer. And we need to return something, so let's return 0 here. Let's see if this is sufficient. Yes, it is. So we should now have an executable file in our binary directory. Let's take a look. Indeed, here it is. Let's delete this for now. And let us now reorganize things. So first of all, I want to rename this run DSO to mono, as it is now working, into run LDSO Twitch to mono. Let's copy that. And let's update this name here. And this as well. And this as well. This should be fine. Let's double check the other files, which is okay, I think. Okay, let us now recompile. And that's it. Now we have run LDSO Twitch to mono. And we have a warning, which I would like to get rid of. But it's okay, I think, for now. Okay, let us see if we can run the executable. So let's cd into the bin directory. And let's try to run this. And it is not throwing an error. Let us print something. Standard cout. HelloWorld. Okay, how was this definition of the include file? I think include Livestream. I think that's it. Oh, I need to build the project again. That's the problem with C++. I was working with Python all the time, so it was different there, or it is different in Python. So now let's make the project again. Let's keep this open and make a new tab. And run the LDSO Twitch mono, and it prints Hello World. Wonderful, it's working. Awesome. Now we have created the Hello World program with a lot of overhead using CMake lists, but I think this way it's quite nice. And what is left here is just filling up the code, which is the actual meat of the implementation, and this will get very interesting. But I think for now we have accomplished quite a lot, which is why I would thank you for your attention, thank you for watching, and see you next time when we try to complete the main function and get into all the different classes and functionality of actually creating this kind of implementation and trying to understand a little bit more in detail how we can make such a nice tool that will read in an image sequence and create this trajectory and point cloud from this video sequence, from this monocular video sequence, which is quite amazing in my view. And we will see next time how to get a little bit closer to that. Okay, thank you very much for watching, for your time, and see you next time. Goodbye.